of triangles. Now, the first concept that you need to know is that the height or the altitude of a triangle is always chosen relative to a specific base. So if you want to calculate the area of a triangle, the first thing that you choose is the base of that triangle. You don't start with the height. Start with the base first, then from the base, you can then determine your height. And the height is also called the altitude. I'm sure you know that. So the first concept that you need to know is that when trying to determine the height of any triangle, okay, you have to choose your base first. So the height or altitude of a triangle is always relative to a chosen base. Like for example, in the first triangle, triangle ABC, if you choose BC as your base, it means that the length from A to BC at that point there, if you draw a line which is perpendicular to BC, then that becomes your height because it has to be perpendicular to the base. But you choose the base first. If you choose, say, AC as your base, means your height will start from here all the way up to here. Right? If you choose AB to be your base, your height will start from that point to that point. It is this diagram. So whenever you want to find the area of a triangle, the first thing that you have to do is choose your base first. Then from that base now, you can draw a line which is perpendicular to that base to a vertex. Okay? This point here is called a vertex. Where two lines in a triangle meet, okay, we call that point the vertex. Okay? I'm sure you remember this from the law. Okay, so a triangle has got three vertices. Okay? And always the height will come into contact with a vertex of that triangle. So with the vertex here, with the vertex there, also have a vertex there. Okay, so the height of a triangle, if you draw the line, is drawn from the base to a vertex of, of, uh, of that triangle which is opposite the base. Right, now when you've got a special triangle like this one now, I'm sure you know this, that if I choose BC to be my base, my height, I have to determine it by construction. Okay, so you construct a line which is drawn from point B to maybe somewhere there, so that this point here will be in line with the vertex. Then you draw a line which is perpendicular to the base, which will be BC. So this point, I can call it point D. So in maths, we say that BD is BC produced. So you've heard about that language, right? So BD is BC produced. So that point D, point B, and point C will be collinear. Remember, I did collinear points in analytical geometry. So point D, point B, and point C will be collinear. I draw a line from vertex A perpendicular to BC or CD, then that line will be my height. Now, you also encounter questions like that, where you want to be able to create a clear right angle triangle. Right? So, just to summarize this, know that the area of a triangle is equal to half times the base times the height. We were taught that in the lower grades. This is important now when you do triangle geometry. Okay. Anybody else with a question before I go on to another aspect of triangles? Now move on. Can I move on? Now, today's lesson is going to be mainly like an introductory lesson to the grade 12 component of geometry. Right? Then, let me erase this. Right. Then, the next aspect under triangle geometry is that two triangles which share a common vertex have a common height. Okay? Now, I've already told you what the vertex is. It is a point where two line segments in a triangle meet or converge. So, if you have got two triangles, okay, they can only have the same height if they share a common vertex. So, like in this diagram here, we've got the big triangle A, B, D, and the smaller one A, B, C. Right? I'm sure you can see that the two triangles share a common vertex there. That's the common vertex. Right? Now, because they share a common vertex, we can conclude that therefore they have a common height. Why? Because remember what I said a few minutes ago, that when you draw the height of a triangle from a base, it is always perpendicular to the base and it is drawn from the base to a vertex. Okay? Therefore, if they share a common vertex and they are drawn like this, it means that because B, C, D are collinear points, right? The height of both triangles is going to be that height there. Which, if I want, I can give it a name. Okay, I'm going to give it a name. If I call this point E, it means our height is going to be E. Sorry, AE. That's going to be our height. So as long as two triangles have they've got points along the base, okay, that are collinear, and if they share a common vertex, it therefore means that they have a common height. Please, this is only true if their bases have points that are collinear. Okay? If the points along there, their bases are collinear and they share a common vertex, then you can say therefore they have a common height. Now, this concept here is very, very important when you're doing calculation later on the proportion theorem, which probably I might introduce on Monday. Okay, but if I have time, maybe I might talk about before this lesson ends. So you have to know that if triangles share a common vertex, it therefore means that they have a common height. But that is only true if their bases have points that are collinear. Okay? So here we can write the area of triangle ABC as half times BC times the H. Also, the area of triangle ACD half times CD times the H. Now, sometimes in this grade, you may be asked to determine the ratio of areas of two triangles, and you need this concept. If you forget it, you'll get stuck forever. You won't be able to do that specific question. And then you end up saying geometry is very hard. Make sure you take note of it. I'm going to come back to it a lot when I start doing examples later on. Right, then if you've got this triangle as well, first thing, remember, you choose your base first. Right? So this is now an upside down triangle, if you want to say it that way. So F, and we call it DEF. Then you also have EFG. They share a common vertex here. Since they share a common vertex and the points along their bases are collinear, it therefore means that they have a common height. Okay, and be aware that we have got three triangles here. We're only going to concentrate on DEG and FG. So the way that I explained here is also the same. You identify your base first, then you determine your height from the base. As long as the two triangles share a common vertex and the points along their bases are collinear, you can say therefore they have the same height. Okay, if you want to write, you want to copy down something, I can give you a minute or two to copy that down. Remember what I told you when on the first day you came to my class, right? In this class, the person who's going to make me smile is the person who gets a distinction. If you don't get a distinction, I won't smile. So what that means is you have to know, if you want to get a distinction in this subject, you have to know your geometry. And please, I want to warn you, don't take lightly this topic. It's not that easy. You have to know your stuff. Okay? You have to know your stuff. I'm going to try my best to make it as easy as I can. All right.
Yes, sir. Not in the investigation date.
Sorry?
How much the investigation date?
About 12.5% for your report now. All right. So before you start doing the proportion theorem or grade 12 geometry, these are some of the points that you have to know. But I'm not done yet. I need to move on to an advanced technique of working with ratios. That's on the next page. And that one is extremely important. Especially if you encounter high order problems. If you don't know it, you get stuck forever. Alright? Okay, just copy this down quickly. You see now, I'm a bit worried about those people who will pursue me. Because this introduction that I am making is extremely important. Alright, so let me carry on. Because some of them I know they will start asking during the lesson. When I start doing higher order problems on this topic, they are going to start asking. Alright, let me carry on with another point. That if you want to copy that down, please copy that. I hope you are following.
So if you continue with the example, you can
Or you can solve it. As long as you are given the ratio, you can solve it.
but it's not yet.
It's not always that. It will depend on what the question is testing. Right? If the question is testing you to determine the length, if you are given some ratios, you can work with those ratios to get the length. Don't try to get there. This is an introduction. You just have to know these concepts. Before you start trying to attempt questions on the proportion theorem, you have to know these concepts. Okay, I wanted to introduce the proportion theorem and then do examples from Monday, but my time might not allow me so. So I think probably on Monday I'll introduce the proportion theorem. These are some of the things that I will talk about. Okay, but make sure you know your basics. Over the weekend, in fact, by Sunday, make sure when you come to school, you've gone over these basics. Because when I start talking about the proportion theorem on Monday and the rest of next week, you need to know what's going on. And this is the background. Okay, let me just mark the register. Okay, Marcelo is not here. Ria is here. Lungelo, no. Leander, no. Kelo, no. Okay, Saracen, you are here. How do you pronounce your name? Saracen, okay. And that's Ria. Sorry, how do you pronounce your name? Jan? How do you pronounce her name? Yeah.
Yeah.
Sian. Okay.
Yeah. Not GN.
Sian. Sian. And what's your name?
My name is Therese. No, it's Therese.
Yeah?
Therese.
Therese. Wow. And what's your name? Huh?
Trey.
Oh, you are Trade. Hmm? You want me to call you Trade? What about you? Oh, you're Jordan. Okay. So that's Jordan, that's Trey, Saracen, Keris, then Sian, then Ria. And what's her name? Tando. Okay, but there's another Tando as well. Okay, we are Tando. Tando Kazi, okay. Karina is not here. Zahud. Where is Zahud? Okay, and then I don't have to talk about it. I don't have to talk about it. And your friend Cashley, where is she? Where is he? Oh, you went to Home Affairs.
Yeah, you get lost. You didn't give it to him.
He also went on.
Yeah, I went to get him. I think I was my.
That was in your photo. Yeah, with block face.
And Samia.
Samia is coming to one.
Samia.
It's something that Google. Samia.
And Jaden too.
Yeah, Jesus probably.
Yeah,
Isn't he alive?
like God. Like
Yeah.
Okay, so can you just tell me that that's in Tandoka's Ria? Now, Ria, your name is very easy. I memorized already. Look at the past days I memorized. Then Sian, Jian, I know. Okay, Keris, yes. Then Saracen, then Trey. Is Trey your full name? Okay, because I know someone called Trey there in this school.
That's a great level.
All right, and then Jordan. I've got a relative with that name, so it might be easy. All right.
Very something.
Okay. All right. So I think for today we'll stop here. You go home and digest everything I said. Okay. On Monday we'll do the proof.